Assalamu alaikum wa rahmatullah. Hi everyone. In this video we will be looking at the second question from the file of question 2 from the coverage of grade 11 elite for term 3. Grade 12 elite for term 3. So, a particle initially at rest moves along the x-axis so that its acceleration at any time is given by a of t, 12t squared minus 4. The position of the particle when t is equal to 1 is x of 1 is equal to 3. So, part A says find the values of t, the values of t for which the particle is at rest. So, at rest, as we agreed before, at rest it means that v of t equals 0. But we don't have v of t, so let's try to find it. So to solve part A, you must find v of t by integrating a of t dt, which will be the integral of 12t squared minus 4 dt. So in this case we have 12t to the power of 3 over 3 minus 4t plus c, right? We can use an initial condition now to find the value of c, where it's given at the beginning of the question. Since the particle is initially at rest. At rest it means v of 0 is equal to 0. So you can just replace v with 0. This is 12 over 3 is 4. 4t cubed minus 4 times 0. I should have written 0 here. Plus c. So you get c equals 0. So the velocity equals 4t cubed minus 4t. We're not done with part A yet because we need to find the t values. So we must now set this amount equals to 0. Factor out 4t. That leaves you with t squared minus 1 equals to 0. So it's either t equals 0 or t equals plus and minus 1, right? 1 and minus 1, but this is rejected because t is bigger than or equal to 0 as mentioned in the question, right? It's here mentioned in the question. So the t values where the particle is at rest are 0 and 1. So this is part A. Now part B says write an expression for the position x of t of the particle at time t is bigger than or equal to 0. So to find an expression for the position, you need to integrate the velocity v of t dt. So x of t would be the integral of v of t, which we already found. It's 4t cubed minus 4t dt, right? So x of t is equal to 4t to the power of 4 over 4 minus 4t squared over 2 plus, should we use c, should we use k, any other letter? Let's keep it k, okay, because we already used c in part A. So x of t is equal to t to the power of 4 minus 2t squared plus k. Now we can make use of the initial condition x of 1 equals 0. So we can use x of 1 equals, I said 0, no, it's 3. It's given in the question. We can use this initial condition to find the constant. So replace x with 3 and t with 1 minus 2, 1 squared plus k. you must get k equals what? 4. After getting k equals 4, x of t becomes t to the power of 4 minus 2t squared plus 4. That is x of t. This is part B. So, let's look at the last part, part C. Find the total distance traveled by the particle for the time interval from 0 to 2, the total distance. Okay, so part C, okay, we need to find the total distance the particle traveled from 0 to 2. Now, at t equals 0, the particle was at rest. And we also found that in part A that the particle was at rest at t equals what? At t equals 1. And we are interested in the total distance from 0 to 2. So the particle at at t equals 1 was at this point. So we have to find it. So x of 0, okay? This is x of t. This one x of t. So I'm referring to this x of t. So if you plug in 0 here, you get 0 to the power of 4 minus 2 times 0 to the power of 2 plus 4. So x of 0 is equal to what? It's equal to 4. Now this is where the particle started moving. It was at x equals 4. Now the particle is started moving. Now for the first, let's say 1 second or 1 minute, the particle reaches what? Let's find x of 1. X of 1 will be 1 to the power of 4 minus 2 times 1 squared plus 4. So x of 1 would equal to what? This is 1 minus 2 is minus 1 plus 4 is 3. So the particle moved from 4 to 3 within the first second, minute, whatever. The unit, I don't think it's given. It doesn't matter. Now, until t equals 2, what happens? The particle now is located at this x value. It's 2 to the power of 4 minus 2 times t squared plus 4. So x of 2 equals what? This is 16 minus 8 is 8 plus 4, it's 12. So what happens here? Now from 0 to 1, the particle moves only 1 unit, right? From 0 to 1, the total distance the particle moved is 1, right? And between 1 and 2, look, at t equals 1, the particle is at 3. At t equals 2, the particle is at 12. The difference between them would be 9, right? So the particle traveled 1 unit from 0 to 1 and 9 units from 1 to 2. In total, the particle traveled 10. This is the total distance. This is the total distance the particle traveled from 0 to 2. Is there any unit given? No, it's just total distance equals to 10. Good luck.